is कि we take two fully controlled rectifiers connected in anti-parallel, right? We take two rectifier circuits or converter circuits connected in anti-parallel, right? Connected in anti-parallel, right? Where do we connect the load? Obviously, they require the operation, they require the AC supply. So depending upon the supply, AC supply, we may have two kind of AC supplies. We may have the single phase AC supply or we may have three phase AC supply. But depending upon the supply available, we will choose the converter. We may have the three phase converter or we may have the single phase converter. Obviously, if we are having a three phase supply, we will be using three phase rectifier, right? Now, this is being fed from here. For the next one, we will take the connections from here. We will take the supply from here and we will feed it to this one. Like this, right? Where we'll connect the motor? We may have an output from here and we may have an output from here. Your load is being or your motor is being connected in between the two. In between the two. Basically, you can connect them directly by having a connections from here to here in between these two. Again, what strategy we are using? We are using the armature voltage control method, right? Whatever we have discussed till date is key. We will be using the armature voltage control, right? Field flux control is not so widely used, as the response obtained from the speed control with field flux control method is sluggish, right? The variation in the field flux is very sluggish. It does not respond very quickly. So armature voltage control method is more used, right? So this is the strategy and we call it as dual converter. Why? Because two converters are being used and both our converters are connected in anti-parallel, right? Using this strategy, we can have the four quadrant operation, as one can provide us the current in the forward direction, whereas the other can provide us the current in the reverse direction, right? If VA is the voltage that is being provided by this converter, let it be a converter and let it be this a B converter, then VB will be the voltage that will be provided by the second converter. Now, there are two schemes to operate this converter. One is that we can operate both these converters simultaneously. Both of these converters can be operated simultaneously. And the other one is we can control or we can operate them singly, means individually, right? Once we will be operating this, we will be keeping this off. And once we will operating this, we will be keeping this off. So there are two strategies to operate this dual converter, right? In the first, when we operate both the converters simultaneously, the care is being taken, right? So there are two methods of controlling. Let me write over here. There are two methods of control for dual converter. Right? In this, the first is called as simultaneous control. And in fact, we call it as circulating current control. The first is when we simultaneously control both the rectifiers, right? This is also called as circulating current control. What we call as, I will tell you why, right? We also call it as circulating current control. The other method is to control them individually, right? And we call it as, in this, one rectifier. The other way is one rectifier is controlled at a time. And what we call this as, we call it as non-circulating current control. What they are saying is basically, when we simultaneously control these two rectifiers, right, the firing angle can ascertain you the non-circulation of DC current, whereas there will still be a AC current that will be flowing in these loops, right? There will be two loops. This, so there will be a current that will be flowing because of the instantaneous difference in the voltages. So to reduce them, these filters L1 and L2, these inductors L1 and L2, they are being used. So they are used to reduce the AC circulating current. But obviously there remains the AC circulating current, small amount of circulating current. That's why we call this as circulating current control. When we are controlling the both in simultaneously, right? Whereas when we operate them individually, means one at a time, then no chance of circulating current being there. That's why we call that as non-circulating current control. We do not require any control to have the control over the circulating current. But when we are operating them simultaneously, to control the DC circulating current, the condition needs to be satisfied that VA should be equal to VB. Means both the voltages generated by the rectifier should be equal, right? Or you can say that your VA and VB, the sum of this VA, because both are in opposite polarity, right? Both are in opposite polarity. So we can write this as VA plus VB equals to 0, because VA is equal to minus of VB, right? So you can say that VA plus VB should be equal to 0. If they are considering this to be a single phase rectifier, then we know that VA will be equal to 2 Vm by pi. If they are fully controlled rectifiers, right? And if they are the single phase rectifiers, although we have taken the 3 phase, but it is being mentioned that for the lower motor ratings, we use the single phase supply. It is recommendable to use the single phase supply. Whereas if the motor rating is high, means higher than the 10 kilowatt, then we use the 3 phase supply and the 3 phase rectifiers, right? So if suppose it's the motor is less than the 10 kilowatt, then obviously we will be going for the single phase supply, and the rectifiers used will be single phase rectifier. If this is the single phase rectifier, the output VA obviously will be equal to 2 Vm by pi cos alpha, right? 2 Vm by cos alpha. Similarly, it will be 2 Vm by pi cos alpha, but in the negative direction. So what we can write, we can conclude from here is ki your cos alpha A plus cos alpha B, it will be 0. From these two, we can write this, where alpha A is the firing angle for the A rectifier, whereas for the B rectifier, the cos alpha B will be the alpha B will be the firing angle for the your B rectifier, right? From here, it has been derived that alpha A plus alpha B should be equal to 180 degree. means sum of these two should be equal to 180 degree. If alpha A is having 90, then alpha B should also be 90, right? If alpha A is having a 80 degree, then your alpha B needs to be operated at 100 degree. Is this fine? Right? So this is the dual converter strategy in which we can have the 4-quadrant operation. Okay. Now let us move ahead. We had discussed about the rectifier fed DC motor drives. Let us move ahead. चाहो तो इसके ऊपर कुछ न्यूमेरिकल्स भी कर सकते हैं, but let us move ahead with the chopper fed DC motor drive. Try to understand the basic concept or basic philosophy behind this chopper fed DC motor control. We already have discussed that there are the two methodologies to control the speed of the DC motor. What are those? Those are armature voltage control and field flux control, right? We also have concluded by this time that yes, the more preferred strategy is the armature voltage control, right? Now, what this armature voltage control we already have discussed. We also know this fact that your armature voltage and the speed of your DC motor, they are directly related, right? If we'll increase the armature voltage, your speed will increase. If we will decrease the armature voltage, your speed will decrease. It's very clear, right? We also have solved some numericals on this strategy, but at that time, your motor was considered to be fed through the rectifier because this up to you was AC. Now what we will be considering is कि suppose we are having a DC power supply, right? But we want to have the speed control of the DC motor. Now supply means obviously DC supply means the fixed voltage supply we will be having. To have the speed variations, we should provide the variable voltage to the armature to get the different speeds. So how your chopper fed DC motor drive will look? If we draw a schematic, it will look like that. Suppose we are having a DC power supply. We can have a DC power supply from here. Right? Now, to feed the motor, what kind of motor we are using? We are using a DC motor. And in this DC motor, let us say we will be using the armature voltage control. So we will be feeding the energy to the armature circuit through this one. The field is being constant. It is being constant, right? So to feed the armature circuit, we obviously could have connected this directly to the DC power supply, but in that case, if we have connected this to directly the DC supply, we could not have got a variable speed. So to get the variable speed, what we'll use is the power modulator, and that will be a DC-DC chopper in this case. I think everyone will agree to me, right? Now the energy flow will be such that your power from the DC will go to the DC converter, and from here this will go to the armature circuit, right? So we will be applying the voltage, that is the terminal voltage, to this, and that is the output of the DC converter to the armature circuit, right? To make this scheme a closed loop, what we can do is we can measure the speed of the shaft. We can measure the speed of the shaft, right? We can take this information back. We can pass it on to the controller. where we will feed the reference value on which we want to run our motor. There the value will be compared and a difference will be generated. Now according to the difference, your control unit will take on the actions, and will try to govern the, what will it govern? It will govern the, what it will govern? बोलो बच्चों जल्दी से, what will this govern? Huh?
Armature voltage.
Oh, it will be governing the duty cycle of the DC converter. As earlier, it was governing the firing angle. When it was a rectifier, what it was governing? Your control unit was governing the firing angle. Now, in this case, it will be governing the duty cycle. So, this will be a schematic of a closed loop control of chopper fed DC motor drive. I think you all now know this functioning of this, right? And obviously, as being shown over here, what strategy is being employed? It is the armature voltage control which we are using. Okay. Now to review the DC converters, I will not go into much detail, but yes, we can classify the rectifiers based upon the, we can classify the choppers that are the DC converters into, on the basis of the input output voltage. Yes or no? Can we classify? बताओ बच्चों जल्दी से. How can we classify the DC converters? Sunil?
Sir, we can classify in which quadrant it will work. Like there are
yes,
5 types.
One of the classification which you could have studied is on the basis of the capability of the converters to provide you the voltage and the current, right? In which quadrant it can provide you the voltage and the current, and there could be the number of classification, number of types of the converters under that category: class A, class B, C, D, E, and F, right? But on the basis of the output and input which we get, we can classify the DC converters into how many categories?
3.
3, right? Very good. On the basis of input output voltage relationship, in fact the output voltage, right, we can classify the chopper circuits into 3 categories. What are those? Bolo?
Buck converter, boost converter.
Right. One is the buck converter. Buck converter means here the output voltage will be less than the input voltage. Yes or no?
Yes, sir.
Boost converters, the converters in which your output voltage remains greater than the input voltage, right?
Yes, sir.
And the third one, which is called as, what we call it as?
Buck boost.
Buck boost converter topology, where the output may increase or decrease depending upon the duty cycle, right? In each of the case, it depends upon the duty cycle, right? We may have output voltage greater or lesser than the input voltage in this case. depending upon the duty cycle. राइट? तो ये 3 कन्वर्टर टोपोलॉजीज पढ़ी. मैं बहुत इसके डिटेल में नहीं जाऊंगा क्योंकि मेरा काम इलेक्ट्रिक ड्राइव्स पे है, तो वी विल बी डिस्कसिंग इलेक्ट्रिक ड्राइव्स. थोड़ा सा ही समझने की कोशिश करेंगे, राइट? Although it's not necessary, but I want to make you remind that in the boost converters, actually each of these three in its simplest form is consists of 3 elements: one inductor, one switch, and one diode, right? Only by interchanging the positions we can have these 3 configurations, right? In fact, we can have multiple configurations, but these 3 can also be made with these 3 elements: one inductor, one switch, and one diode. So in case of buck converter, your switch is being connected. The switch means the thyristor, right? Or any controllable switch, MOSFET, IGBT, right? Now in the buck converter, switch is being placed just in this fashion, where L is being connected to this. So this is the configuration of this is the schematic for the which converter? Buck converter, right? If we talk about the boost converter, in the boost converter, these are the 3 elements: 1, 2, and 3. Only the position will interchange, right? In the boost, first we will have inductor, switch will be over here, right? There will be a switch and there will be a diode. This will be your boost configuration. Right? In the third one, your switch is being placed just like your buck converter, but the remaining 2 elements interchange their position. Means your inductor will be over this place, whereas your diode, but in reverse direction, right, will be here. And we call it as buck boost topology. Right? Buck boost. Basically, the output of each of this converter, it depends upon the opening and closing of this switch, right? And opening and closing ratio is called as duty cycle, right? So duty cycle is what? Duty cycle is being defined as the period of T on to T on plus T off. For each of the case, we'll define the duty cycle D by this fashion, right? That means if T is the switching period, total time period is the T is the switching period, then for how much period it remains on, right? This is the total T and this is the T on and this is the T off. Then remaining will be the T off, right? This will be T off. This you could have learned, right? Now for the ratio of this T on to the total time period is called as the duty cycle. So by controlling the duty cycle, we can have the control over the voltages of these 3 type of converters, right? In these converters, hopefully you also remember this fact that in case of buck converter, the relation between the V0 and Vin is equals to, with regards to duty cycle, is equals to V0 is equals to how much? Follow? If D is the duty cycle, then it will be equals to D times of V in for the buck converter. Do you remember? Do you remember? बोलो बच्चों. अरे हाँ ना तो बोल दो भैया. हाँ
Yes, sir. Yes, sir.
ये सुनो, कुछ तो बोलो कि हाँ भाई याद आ रहा है सर कि नहीं आ रहा है.
Yes, sir. Yes.
Right. What about the boost converter? How do your V naught and V in are related? V naught is equals to, for boost,
V in by 1 minus D.
बताओ जरा. हाँ who will tell? हर्ष, आप बताओ. अरे बोलो जल्दी से.
सर सर भी ठीक से याद नहीं है सर.
किसको याद है ठीक से जल्दी बताओ. जल्दी बताओ किसको याद है. अरे किसी को याद है?
Sir, V in over 1 minus D.
Yes, it will be V in over 1 minus D. Basically, V naught upon V in is equals to 1 upon 1 minus D. This is the relationship, right? This is the relationship. कि V naught upon V in is equals to 1 upon 1 minus D. याद आ रहा है कुछ? Where D is the duty cycle. What about the buck boost converter? It have relationship that V naught will be equals to D upon 1 minus D into V in. This will be the relationship for the buck boost converter, right? You can see that this D maximum can have a value of 1, right? D can maximum have a value of 1 because it's the ratio of T on to the total time, right? Maximum time period for which you can keep your switch on is T, right? So maximum time will be equals to this T over T, that will be 1. Is this clear? So maximum value of the duty cycle could be 1. So that means your duty cycle D will always have a value lesser than the 1, right? It can be up to 1, maximum up to 1, but that means it will be in between 0 to 1. It may vary between 0 to 1, right? 0 in that case ki we haven't on the switch, it always remains the off, in off position. That means that at that time duty cycle will be 0. Your duty cycle will be 1 when your T on becomes equals to T, right? That is total time period. T on plus T off is equals to T, total time, right? So you can see from this that in case of buck converter, because your D can vary from 0 to 1, so always this converter can give you a voltage, output voltage, that will be either equals to 1 or less than 1, or either equals to V in or less than V in, right? Because this D can have the value in between 0 to 1, right? So maximum this D can be 1. When this D will be 1, that means the output will be equals to V in for buck converter. लेकिन अगर D की वैल्यू 0.5 हो गई, that means output will be reduced by half, right? That's why in case of buck converters we get lesser voltage than the input voltage, right? We'll get the lesser voltage than the input voltage. If we put a equals to sign over there, we'll have a less than or equals to. This equals to means putting the value of D equals to 1. Similarly, if we put the value of D, this D can be varied from 0 to 1. If suppose we are having the D equals to 0.5, how much will be the voltage in terms of V in for the boost converter? How much will be the voltage? बोलो. अगर D की वैल्यू 0.5 रखता हूं तो बूस्ट कन्वर्टर के केस में V नोट कितना हो जाएगा V इन के रेस्पेक्ट में? हाँ बोलो, सही है? अरे बोलो जल्दी.
ट्वाइस हो जाएगा.
हाँ
2 times.
1 by 0.5 1 by 0.5 हो जाएगा ना. अगर D की वैल्यू 0.5 रखी तो 1 minus 0.5, 1 minus 0.5 means 0.5, तो it will be 1 by 0.5, that will be 2. Half means,
yes sir,
That means it will be 2 times of that V.
Yes, sir.
Yes, sir.
है ना? That will be, it will be 2 times of V in. तो कह सकते हैं कि बूस्ट कन्वर्टर के केस में आउटपुट वोल्टेज बढ़ जाएगा, राइट है? बक बूस्ट के केस में if your duty cycle is greater than 1, if D is greater than 1, let it be 0.7, what will be the relationship? Your output ज्यादा होगा V in से कि कम होगा? अगर D की वैल्यू 0.7 ले रहा हूं तो मुझे बताओ कि V0 V in से बड़ा होगा कि छोटा होगा?
बड़ा।
हाँ, 0.7 डिवाइड बाय 0.3 होगा. देखो बक बूस्ट की बात कर रहे, बक बूस्ट में रिलेशन इज कि V0 will be equals to D over 1 minus D into V in, right? Suppose let the D is of 0.7. देखो अगर वो 0.5 होगा, exactly 0.5 होगा तो क्या होगा? V0 will be equals to V in. Yes or no?
Yes, sir.
Yes, sir.
अगर D की वैल्यू if D is 0.5, then V0 will be equals to V in this case, no doubt, क्योंकि D 0.5 1 minus 0.5 0.5 0.5 0.5 कैंसिल हो गया. लेकिन if D is greater than 0.5, let it be 0.7, then what will be the case? V0 will be higher than V in or it will be less than V in?
Sir, more than V in.
It will be 0.7 divided by 0.3. That will be 7 by 3. That means it will be higher than the V in. Yes or no?
Yes, sir.
But what will happen if D is less than 0.5? Suppose take a case of 0.4. V0 will be equals to less than V in or higher than V in?
Sir, less than.
Right. Then in that case, it will be less than V in. So we can see that in case of buck boost converter, we can get the higher voltage than the input voltage that we have applied on the input side, or we can also get the voltage that is lesser than the input voltage depending upon this duty cycle, right? So we can control the voltage on both sides. We can have the higher voltage, we can have the lower voltage which we have applied, right? But keeping this in mind, we had to keep this also in mind that in case of armature voltage control, we don't go beyond the rated value, right? We don't go beyond the rated value. So if we are having a converter that is giving you an equivalent value, right? If your converter input is equals to the rated voltage of your motor, then which kind of converter you are going to use? मैं बोल रहा हूं, हम आर्मेचर वोल्टेज कंट्रोल की लिमिटेशन वी नो कि वी कैन नॉट अप्लाई अ वोल्टेज ग्रेटर देन द rated voltage, right? We cannot apply across this armature the voltage greater than the rated voltage, right? We have to select the converter now, this DC converter, for which case, a case is that we are having on the input side the voltage source that is giving equal voltage equals to the rated of this, right? This voltage is equals to V rated of this machine. Then which converter we will be using?
Sir, buck converter.
Right. That's why what we'll use is the buck converter. Because we don't want we cannot apply a voltage higher than the rated one. Right? So we'll go for the buck converter. That's why you will see that in case of, in this book, that is the GK Dubey, they had solved the two numericals and they haven't mentioned that whether they are using the buck converter or the boost converter, but you will see that the operation they have described is basically for the buck converter, and that this is the reason, right? So we'll be using the buck converter, and obviously by controlling the duty cycle of this buck converter, we can have the control over this voltage that will be applied, right? ठीक है राहुल, योर mic is unmuted. Keep your mic on mute, please. Right. And in this way, we can have the closed loop control. Is this clear, bachcho?
Yes, sir.
Right. Now, keeping this in mind, let us have a very, very small numerical, then I will leave you as I'm having another class. It's the same question which we performed or which we did with the rectifier control drives. The numerical is such that they are saying that at 230 volts, 960 RPM and 200 ampere separately excited. कैसी मोटर है? सेपरेटली एक्साइटेड मोटर है. सेपरेटली एक्साइटेड डीसी मोटर. 3 लाइन में आंसर है केवल भाई, मैं इतना ही पूछना चाहता हूं. डीसी मोटर हैज एन आर्मेचर रेजिस्टेंस of 0.02 ohm, right? Now they are saying the motor is fed from a chopper. Again, see, they are not saying whether it's a buck converter or a boost converter, but they are saying that it's a chopper, right? Chopper which provides both motoring and braking. बस यही लगाता हूँ मैं फुल स्टॉप, है ना. मैं ये नहीं कहता हूँ कि ये क्या है कहानी, आगे यही बनाता हूँ, क्वेश्चन छोड़ देता हूँ. ठीक है. नाउ दे आर सेइंग द source means the input to this chopper has a voltage of 230 volts, right? Assuming continuous conduction mode, what they want us to is they want us to calculate duty ratio, which we can also call as duty cycle D of chopper for motoring operation at rated torque and 350 RPM of speed, right? How do we have a solution? First, you have to keep it in mind that they are talking about the separately excited motor. That means in the separately excited, the armature will be fitted with the different supply and we are controlling that, right? So in that case, this field flux phi, it will remain constant because it's a separately excited motor. Is this clear, bachcho? We want to have the armature voltage control, so that means we will be controlling this VT. And earlier your motor is of 960 RPM. That means when we apply 230 volts across the armature, your motor will run at 960 RPM, right? It will take 200 ampere and it will run at 960 RPM. What we want is 350 RPM. That means obviously we had to apply a lesser voltage than the 230 volts. We had to calculate that, right? And this time we are feeding it with the chopper. So we had to control this chopper cycle D. कैसे करेंगे? First we want to have this VT on which we can have a 350 RPM of speed. How can we calculate that? Simply by knowing that at rated operation, the E that will be generated inside the motor, how much it will be? E will be equals to VT minus IARA, yes or no? How much this E will be? VT कितना हैगा rated के केस में? It will be 230. करंट कितनी है? 200 एम्पियर. आर्मेचर सर्किट रेजिस्टेंस कितना है? 0.02 ओम. So how much will this E will be? Answer is
26 volts.
226 volts. So that EMF that will be generated in the armature circuit at rated conditions will be 226, right? Okay. What will be the EMF that will be required or that will be generated at 350 RPM? That we can calculate. Assuming that we know that it's a separately excited motor, and we also know that E is proportional to phi n. But in case of separately excited motor, this phi is also constant. So we can write that E1 is equal to N1, and we can write that E2 will be equal to N2. N2 is the 350, N1 is the 960. So we can write that E1 means at 226 your speed was 960. Then we require E2 for 350. So by dividing these two, can we have E2? Yes, we can have E2 by putting this equation. Yes or no? How much will be value of E2? E2 will be equal to
82.39.
82.39, and let it we write as 82.4 volts. Right? ठीक है बच्चों? We have E. Can we have the value of V that we need to apply across the armature of this motor? See, we have E, but for this E, how much V we need to apply? We know that E2 must be equal to V2 plus or minus V2 minus IA2 or RA2. Yes or no? Bolo?
Yes, sir.
So we want V. What we want is V. V wants V. V will be equal to E plus IARA. मैं ऐसे लिख सकता हूँ. Directly मैं लिख रहा हूँ. Here V for the second case will be equal to E2 plus IA2 RA. RA तो मुझे पता है, E2 मैंने कैलकुलेट कर लिया 82.4. RA की वैल्यू 0.0 कितनी थी? 2. What I don't have is value of IA2. मीन्स जब ये स्पीड कम हो गई होगी तो आर्मेचर कितना करंट ले रहा होगा. ऑब्वियसली उन्होंने कहा कि रेटेड टॉर्क पे जो पहले चल रही थी वो अभी भी रेटेड टॉर्क ही प्रोड्यूस करना है. टॉर्क हमें पता है, इट इज प्रोपोर्शनल टू phi IA. Again, in this case, your phi is constant because it's a separately excited motor. So, for this case, torque will be proportional to IA. That means अगर rated torque पहले भी था तो पहले rated current ले रही थी, तो अभी भी तो torque constant है. That means IA will be same as the rated one, right? So, how much is the rated current? The rated current is equals to 200 ampere. वो उसने दिया हुआ है. So, how much will be the voltage that will be required? बोलो जल्दी.
86.4.
86.4 volts. So that voltage we need to apply, and that is the voltage we need to apply. For this we have to control this duty cycle. If it's a DC converter, right? If it's a buck converter, and on this side we had applied the 230 volts, right? But we want only the 86 point something, right? Then how much will be the duty cycle of this D which we have to maintain if it's a buck converter? कितना होगा? भाई we know that in case of buck converter V naught will be equal to D times of V in. V in is 230. V naught we require is 86.4. So can we calculate this D? D will be equal to 86.4 divided by 230. Yes or no?
Yes, sir.
Bolo?
Yes, sir.
It will be 86.4 divided by 230. So how much the value will be? It will be 0.376. So this will be value of duty ratio. चलो ठीक है, आज के लिए इतना ही काफी है. Everybody